Welcome to the First Mold Insights, where we talk about injection molding, rapid tooling, product development, and real world manufacturing insights. Today's topic is understanding design for manufacturing for plastic products. Alex, we hear a lot about DFM or design for manufacturability. It's a term that gets thrown around quite a bit in product development circles. From your perspective, working on the shop floor for so long, what's the fundamental problem DFM helps engineers and product teams solve, especially with plastic parts?
Well, Mia, the biggest thing DFM does is pull manufacturability right to the front of the design process. You know, you're not waiting until you've got a fully fleshed out design ready for tooling, only to find out you can't actually make it or it's going to cost an arm and a leg because of some feature you put in. It's about looking at how you're going to build something right from the start. For plastic products, specifically, that means considering the molding process, the assembly, all that good stuff, even before you cut steel for a mold.
Huh, okay. So it's about catching potential headaches before they become full blown migraines on the production line. What does that actually look like in practice for plastic products? I mean, what aspects are we analyzing?
Right, exactly. So, for plastics, you're essentially analyzing the design information for process feasibility. We're looking at things like the material you've chosen, is it suitable for the part's function and for injection molding? We're evaluating if the product can actually be molded efficiently, and then, most importantly, we're giving suggestions for design improvements. The goal is always the same: lowest cost, shortest time, highest quality. We're talking about everything from shrinkage, mold steel selection, wall thickness analysis, where your gating positions will be, your parting lines, draft angles, ejection points. You get the idea? Sometimes we even incorporate mold flow analysis to predict things like optimal gate positions, where sink marks might show up, or potential weld lines and gas traps.
That's a lot to consider. It sounds like a pretty structured process. Is there a typical point in the product development cycle where this DFM analysis usually happens?
Yeah, there absolutely is. Traditionally, and this is still how it works in over 98% of processes we see, the DFM report gets created after the product design is completed, but crucially, before mold development starts. So, the product development team finishes their design, hands it over, and then the manufacturing side, or the mold designers, generate this detailed report. The engineers on the product side then take that feedback and make iterative adjustments to their product structures. They're trying to meet the mold design and processing requirements and, minimize those injection molding costs.
So, it's a feedback loop, then, where the product design gets refined based on manufacturing realities. What are the big advantages of doing this DFM analysis? Beyond just avoiding problems, what kind of benefits do product teams actually see?
Oh, the benefits are huge! Firstly, it just minimizes those assessment gaps later on. You're preventing defects, avoiding elongated development cycles, and not suddenly seeing costs balloon. Secondly, it really streamlines the whole development process. Engineers and teams become more efficient, cutting down both development time and costs. Thirdly, it lets you make real-time design modifications. You can optimize the design for high-quality products, improve manufacturing efficiency, and again, reduce those production and development costs.
Real-time modifications sound powerful. Does DFM also help with material selection or environmental considerations?
It absolutely does. We can perform material impact analysis, for example, to make sure the selected materials meet environmental standards. That's becoming more and more critical for an eco-friendly approach, avoiding pollution and all that. And another big one is synchronous mold flow analysis. That really gives you a genuine preview of the injection molding process. You can evaluate equipment needs, processing parameters, and guide the mold design effectively. Plus, all of this feeds into a cost-benefit analysis, which optimizes the product design to reduce mold, material, and production costs, ultimately enhancing competitiveness.
Okay, so DFM reports are clearly super valuable, but how does one actually make a DFM report? What goes into it? I imagine it's not just a simple checklist.
No, it's definitely not a checklist. It really reflects the expertise of the designer putting it together, and it showcases the technical prowess of the mold company. You're typically using specialized software like UG for the design analysis, along with screenshot tools and presentation software like PowerPoint to compile it all. It starts with a basic table of contents, just like a book giving an overview.
And then, what's in the actual body of the report? What are the key sections a product designer would look for?
Alright, so you'd start with the basic information. This gathers crucial details about the product and mold itself, the plastic material, process conditions, the mold number. It's super important to confirm all this with the customer. Then you get into product craftsmanship requirements. Here, we're documenting the customer's needs for product size, surface specifications, things like that. If they want a specific texture or plating, we need to show them visuals for confirmation.
So it's not just about what can be molded, but also what the customer wants the final product to look like and how it needs to perform.
Exactly. Next is the injection method and position. This is where we lay out critical mold design details, where the gate entry point will be, the size of the runner, whether we're using a hot runner or cold runner system, even the specific brand of hot runner if needed. All of this needs customer confirmation because it profoundly impacts the part. Then, draft angles analysis. This is huge. We check if the draft angles on the core and cavity are sufficient, especially if the part has textures or special treatments. You need that draft to get the part out of the mold without dragging or scuffing.
Right, avoiding those drag marks is crucial for quality. What else?
You've also got parting line confirmation. We determine where the product's parting line and clip lines will be. This is about ensuring proper placement and assessing the overall reasonableness of the parting. A poorly placed parting line can be a real headache, both aesthetically and functionally. Then, ejector position confirmation. We figure out the ejector pin method and their specific placement to ensure the product smoothly ejects from the mold. You don't want witness marks or, worse, part damage from ejection. And then, wall thickness confirmation. This is vital. We analyze the uniformity of the material thickness, identifying potential issues like sink marks. Red areas in the analysis usually mean shrinkage risks, and will suggest modifications or material reductions.
Wall thickness and sink marks. That's definitely a common challenge. Is there a section for proactively addressing problems?
Absolutely. That's the product problem analysis and solutions section, and it's a huge indicator of the mold designer's expertise. We identify potential issues and propose fixes. Fewer problems usually means a more advanced product development to begin with. And finally, for complex customer requirements, we'll often include mold flow analysis. This report covers filling time, air trap analysis, weld line analysis, system pressure, and so on. It all needs confirmation with the customer.
Wow, that's incredibly comprehensive. It sounds like the mold designer really carries a lot of the DFM responsibility. But I've heard there's a bit of a debate about who should be primarily responsible for DFM. Is it the product designers or the mold designers?
You've hit on a really controversial topic, Mia. The mainstream view, for a long time, has been that DFM should be handled by mold designers. The reasoning is pretty straightforward. Not every product designer is highly proficient in molds and injection molding. It's about specialization, right? You trust professionals with professional matters.
That makes sense from a technical expertise standpoint, but I've also heard arguments for product designers taking the lead. What's that perspective?
Well, the newer viewpoint argues that DFM is really a team effort, but with the primary responsibility falling on the product design engineers followed by manufacturers. There are a few strong reasons for this. First, it helps reduce costs. Manufacturers and product designers often have different, even conflicting perspectives on cost. A manufacturer might naturally lean towards higher product costs for better profit, whereas a product designer is focused on minimizing costs while ensuring smooth production. If the manufacturer leads, they might not actively inform designers of every cost-saving measure.
That's an interesting point about the incentive structure. What's the second reason?
The second reason is about shortening the product development cycle. If manufacturers handle DFM, they typically only start after the detailed product design is complete and the product's ready for mold manufacturing. But at that stage, it's often too late. If DFM wasn't considered from the start of product design, the manufacturer's report will inevitably highlight many areas needing modifications. And making modifications to a finalized design is time-consuming and labor-intensive. Even a small change can cascade across multiple components. So involving product designers from the start avoids all those repetitive modifications and speeds things up.
So it's about shifting DFM left earlier in the process to avoid costly rework. And what's the third point for product designers leading?
The third point is that manufacturer-led DFM can't fully replace a design perspective. A supplier's DFM report purely views the design from a production perspective, but a DFM from a design perspective includes more, things like wall thickness design for strength, overall aesthetics, and broader cost optimization opportunities for the product, not just the mold. You'd miss opportunities to optimize appearance, strength, and overall product cost if you just relied on the manufacturer.
It sounds like a complex balancing act, then. So, what's First Mold's take on this? Where do you stand on who should lead the DFM process?
Look, in our opinion, DFM isn't just a technical aspect. In a way, it's more like a mindset that needs to be embedded throughout the entire product realization process. Narrowly, yes, it's about considering production conditions for manufacturability. But broadly, it's about ensuring the design meets diverse production requirements, offering more choices, and ultimately driving down costs. It's about design for money, creating value through smart design.
Design for money. I like that. So it's not either or, but more of an integrated approach?
Exactly. It's undeniable that manufacturers like us provide DFM, but that process has to involve timely feedback to clients. And we have to convince them with a customer-oriented approach to achieve mutual benefits. But for product designers, being able to grasp DFM techniques themselves, that's hugely beneficial. It doesn't just lead to better product designs, it really enhances their own capabilities as engineers. It's a win-win, really.
So, a DFM report is really about analyzing the product from both the product side and the tooling side. And once that comprehensive report is done, the next crucial step is a detailed discussion with the customer to review and confirm every item before moving forward with mold design.
That's right. That final discussion is key to make sure everyone's aligned and we build exactly what's needed.
Thanks for tuning in. For more manufacturing resources or custom part production services, visit firstmold.com. We'll see you next time.